Hello friends, in this video I'm going to explain you the procedure of testing the hypothesis. I will explain the key terms used in the process such as level of significance, decision criteria, power of test, type 1 and type 2 error, etc. So watch this video for better understanding. We use inferential statistics because it allows us to learn more about the behavior or parameters in the population based upon the sample. We do so because collecting data from large population is difficult and time-consuming exercise. For example, in terms of mean, we measure a sample mean to learn more about the mean in the population. We begin by stating the value of population mean, and then we select a sample and measure the mean in that sample. On an average, the value of the sample mean will be equal to the population mean. The larger the difference between sample mean and population mean, lesser is the chance that we could have selected that sample mean if the population mean is correct. Hypothesis testing or significance testing is a method of testing the claim about the parameters in the population using the sample data. There are 4 steps of hypothesis testing. Number 1, stating the null and alternate hypothesis. Second, state the criteria for decision making. Third, compute the test statistics. And fourth, based upon the test statistics, make a decision. We begin by stating the null hypothesis and alternate hypothesis. Null hypothesis is a statement about the population parameter, such as the population mean, that is assumed to be true. In our examples of children watching TV, we may assume that the children watch on an average 3 hours per week. The null hypothesis is the starting point. We will test whether the value stated in the null hypothesis is likely to be true or not. Just like the analogy of the innocence in courtroom. When a defendant is on trial, the jury assumes the defendant as an innocent person. Alternate hypothesis is a statement that directly contradicts the null hypothesis by stating that the actual value of the population parameter is either less than, greater than, or not equal to the value stated in the null hypothesis. If we have sufficient reason that the children do not watch TV more than 3 hours per week or less than 3 hours per week, we may set non-directional hypothesis. Otherwise, it can be a directional hypothesis. The second step is setting the criteria for making the decision. To set the criteria for a decision, we state the level of significance. This is similar to the criterion jury uses in a criminal trial. Jury decides whether evidence presented by the lawyer show the guilt beyond a reasonable limit. This reasonable limit is called as level of significance. So in hypothesis testing, level of significance refers to the criteria of judgment upon which a decision is made regarding the value stated in the null hypothesis. In behavioral science, the level of significance is typically set at 5%. When the probability of obtaining a sample mean is less than 5%, if the null hypothesis were true, then we reject the value stated in the null hypothesis. As discussed in the previous slide, you must remember that alternate hypothesis determines whether to place the level of significance in one or both tails of the sampling distribution. If we assume that on an average children watch TV less than 3 hours per week, then we will place the level of significance in the left tail. Here you can see, if we assume that on an average children watch TV more than 3 hours per week, we will place the level of significance in the right tail. But if we are uncertain about that number of hours children watch TV, then it will be non-directional hypothesis and we will place the significance level in both the directions, in both the tails. Third step is computation of test statistics. In order to compute the test statistics, we have to choose an appropriate test of the hypothesis. Selection of the appropriate test of hypothesis depends upon the nature of relationship or difference or association conjectured in the null hypothesis and the type of variables used to measure the same. After selecting the test of hypothesis, now compute the test statistics for the test. The test statistics is a mathematical formula that allows the researchers to determine the chance of obtaining the sample outcomes if the null hypothesis were true. Suppose, in our example, we measure the sample mean equal to 4 hours per week that children watch TV. To make a decision, we need to evaluate how likely this sample mean is if the population mean stated by the null hypothesis, that is 3 hours per week, is true. We use this test statistics to determine this likelihood. It is used to make a decision regarding the null hypothesis. The last step of hypothesis testing is making a decision. We use the value of test statistics along with the p-value associated with it to make a decision about the null hypothesis. P-value is the probability of obtaining the sample outcome given that value stated in the null hypothesis is true. The p-value for obtaining a sample outcome is compared to the level of significance. Significance or statistical significance describes a decision made concerning a value stated in the null hypothesis. If the p-value is less than the level of significance, that is 0.05, we reject the null hypothesis and we reach a significance. If p-value is greater than the level of significance or 0.05, then we retain the null hypothesis and also we conclude that we fail to reach the significance. In making decision related to the hypothesis testing, researcher can make two decisions, either to reject the null hypothesis or retain the null hypothesis. When the decision is to reject the null hypothesis, we may be correct or incorrect. Type 1 error is the probability of rejecting a null hypothesis that is actually true. This is denoted by the level of significance. Researchers directly control for the probability of committing this type of error by changing the level of significance. The power in hypothesis testing is the probability of rejecting a false null hypothesis. It is the probability that a randomly selected sample will show that the null hypothesis is false when the null hypothesis is indeed false. When we decide to retain the null hypothesis, we can be correct or incorrect. The correct decision is to retain in two null hypotheses. This decision is called a null result or null finding. This is usually an uninteresting decision because the decision to retain what we already assumed is not very much important. For this reason, null results alone are rarely published in the behavioral research. The incorrect decision is to retain a false null hypothesis. This decision is called as type 2 or error or beta. Type 2 error is the probability of retaining a null hypothesis that is actually false. While it is an error, we still did nothing. We retained the null hypothesis. We can always go back and conduct more studies. Now, which type of error can be controlled by the researchers? Inevitably, errors can occur when making inferences from the sample about testing the hypothesis. Type 2 error is the inverse of type 1 error. It means that if we reduce our chance of making a type 1 error by setting the significance level to 0.01 or 1% rather than 0.05 or 5%, we increase our chance of making type 2 error by a corresponding amount. You can see in this chart if you increase the level of significance from 5% to 1%, the chance of type 1 error decreases, but at the same time, the chance of type 2 error increases. It is therefore generally more important to minimize the type 1 error than the type 2 error by changing the level of significance. This is the reason that we keep the level of significance in social sciences as 5%. Thank you. So friends, hope you liked the video. For more updates on similar videos, please like, share, subscribe and press the bell icon for the immediate notifications.